There are a few best practices for setting up web API tests using ASP.NET Core in terms of what kinds of tests to write and how to configure your application to be tested. The first best practice that I want you to remember about testing web APIs in ASP.NET Core is to just do it. It's so easy once you have a working example that there's really no excuse not to do it. Having automated tests will help you catch bugs and regressions faster, and ASP.NET Core integration tests are a quick and easy way to achieve this. Now, when we talk about API testing, we should be clear that we are not talking about unit tests, or at least not my definition of unit tests, even though there are some variations. My definition is unit tests only test the method under test, and they only test your code. They don't test dependencies. Only test the method, right? So if we're talking about an API, we're talking about an endpoint or a controller action. And if that is the case, then that means that your unit tests, by definition, do not test routing, filters, dependency injection on the controller, typically. Not whatever you decide to pass in yourself in your test, but the actual mechanics of dependency injection in your application. They don't test middleware, they don't test model binding, they don't test model validation. None of these things are covered by unit tests. However, functional tests, also known as integration tests, will test all of these things. Here's what unit testing an API endpoint would look like. It instantiates the controller directly. It calls its action method directly, and then it makes assertions on the result. It can't tell you if routing or authentication or exception filters or any other filters are working properly, which means to verify that, you'll need to create other tests that will do everything this test does, plus test those things. Unit tests for API endpoints tend to be very brittle too, since if you refactor to move logic out of the endpoint and into middleware or into a filter or some other way of doing that that's part of MVC or ASP.NET Core, your unit tests that expect that functionality to be right here in this method, that action method, will break and will need to be refactored as well. Given that we're keeping our endpoints small and keeping as much logic out of them as possible, using fast integration tests should suffice for all of our API testing needs, and they will test all of the components of ASP.NET Core that are used as part of hosting those APIs as well. Now, if you haven't been doing testing, one of the first things you'll need to do is choose a test framework or library. My recommendation for you is to use XUnit. The reason why I am saying that you want to use XUnit is because it is what Microsoft uses to test ASP.NET Core itself, which alone makes it a compelling choice. You can go out to GitHub and look at the source code for any of the ASP.NET Core or .NET Core libraries and see that they are being tested using XUnit. In fact, I encourage you to look at that so that you see patterns for how to use XUnit and how to organize your test code. XUnit also has better test isolation than some other libraries like NUnit, since every test runs in a new instance of the test class, rather than reusing that instance of the test class. This reduces the likelihood of tests impacting one another. Better isolation means your tests are going to be more robust. XUnit has comparable features to other libraries like NUnit or MSTest, so generally that is not a major consideration. If you are already invested in another library, it's probably not worth the effort to switch to using XUnit, but if you don't have a strong opinion or existing investment, choose XUnit. Now, ASP.NET Core integration tests start with Web Application Factory. In fact, you can work with Web Application Factory in your tests directly. However, your test may end up looking like this, so I don't recommend it if you have more than a few tests. There's going to be a lot of duplication, and every test is going to be very long. I realize that this is probably too small to read, especially on smaller devices, so let me break it up a bit. Let's replace the actual web host configuration that was in the previous slide with just a comment here that says that we're going to configure the web host. This will let you see the general structure of an ASP.NET Core API integration test, sometimes called a functional test to differentiate it from other kinds of integration tests. This test is using the standard arrange, act, assert pattern with comments to help you see each section. In the arrange section, the application is configured and then used to create an HTTP client, which is assigned to the client variable. In the act step, the client makes an HTTP request to the application specifying a route. Then it deserializes the response into a strongly typed DTO. Finally, the assert step makes assertions against this DTO in a strongly typed manner. Now, let's return to that configuration of the web application, which was hidden behind that comment a moment ago. The With Web Host Builder extension allows you to use a Lambda to configure the web host using a Web Host Builder instance. In here, we are using it to set some things up for logging. We are configuring it to use a testing environment name, which may be used by our system under test to configure things to work better for testing. It also removes the existing EF Core configuration and replaces it with a new in-memory database implementation. Finally, it calls database.ensure created to seed this in-memory database, resulting in a clean, consistent instance of the application for each test to run against. Now in this case, this is in a single test, so this test will work, but obviously this is a lot of code to have in one test method, and we would have to repeat this code in every other test for our APIs in order to continue to be able to use this solution. A better approach that lets us follow the don't repeat yourself principle is, instead of working with Web Application Factory directly in every test, a better option is to define one or more custom Web Application Factory subtypes in your test project. Many applications will only need one instance, but you might want multiple if you want some tests to use different infrastructure or services from others. For example, you might have some tests that work perfectly well using the EF Core in-memory provider, but other tests would need to use a real database or an instance of SQLite because they depend on more relational functionality. Likewise, you may configure authentication or authorization differently for some tests than for others, and you could do this using separate Web Application Factory subtypes. The custom Web Application Factory subtype shown here, called Web API Application, simply inherits from Web Application Factory of T and specifies a type that lives in the web project that is being used to host the API, typically program or startup, but any type in the project should work. Here again, we are configuring test output to work with our test framework, and then the bulk of the work is in the create host method, where the same code that we saw in the last slide is used to configure hosts created by this type. Once you have a custom Web Application Factory class, you can use it to create a client in your test class's constructor, which is not shown here. Then, each individual test will need little, if any, arrangement, since the bulk of the arrange step is happening in the factory and the seed data methods. The rest of the test steps are the same as before. And we'll see how we can further reduce the amount of code involved in this test in a later part of this module. Now let's jump into the code and see how using Web Application Factory, either directly or through a child type, can help you to test your web APIs. First, let's look at the one that includes the entire Web Application Factory setup in the test class. Notice how long this test is. This test includes everything you need to configure the web host inside of the test method, just as we saw. Overall, this test is about 92 lines of code for the whole class, and just this one method is probably about 60 lines of code, and that is way too long for what I would like to see in a test. You can see though that this test is passing, and so it does work. Now if we refactor this, as we showed, we can put more of that logic into the Web Application Factory. The other thing that is worth pointing out here is that although we're not using magic numbers for our IDs, I'm using a test author ID here on line 82, and I've specified that also up in the top on line 23 to be ID 1. But that is kind of a magic number, and I have to know that when I set up my test data that there's going to be a corresponding record for that ID. Also note that In the end here, where we're asserting what the name is of that first author, I am hard coding that magic string to be Steve Smith. If I ever update the seed data, this test is going to no longer work. So it's very tightly coupled to the current implementation details of the seed data. Speaking of which, let's look at that seed data. The seed data is configured in the author config class used to configure the entity. Inside of each one of your entity type configuration classes, and you can also just do this in the DB context itself, you can specify that it has data and then give it a collection that you want it to be populated with. In this case, I have a static method called seeddata.authors, and it's defined in the backend data project. If we take a look at that method, we see the authors method is just a static method that returns a list of author, and it's hard-coded to return Steve Smith and Julie Lerman with IDs of 1 and 2. Now, we can use that information by directly referencing this seed data from our test. So now let's look at the combined test that uses a custom web application factory and is going to do its assertions based on the seed data itself. So right away, this version of the test class is much shorter. You can see it's less than 50 lines of code for the whole class, and the test itself is fewer than 10 lines of code, not counting comments. In here, we see now that we have the collection of authors being set to a property on the test, with the intention being that we would use it again for other tests. And then inside of our single test we have here, we're specifying on line 36, the first author's ID is the one we want to go fetch. And again on line 46, we're specifying that that first author's name is the one that we expect. And again, you can see that this test passes. Finally, if we look at the custom web application factory, in this case called Web API Application, you can see that this is where we are overriding the create host method. And in this method, our job is to specify the environment, set up logging, configure services to remove the default DB context setup, and replace it with an in-memory database setup. Then, in order to do the seeding of the database, we need to create a scope, because a DB context requires a scope in which to run. And so there's a little bit of work there to create the scope. But once we have that scope created, the important line of code that is doing the seed data for us is the one that says database.ensure created. And that's all we need to then write as many different API tests as we want using this same Web API application class.